Good day. You can see we're looking at electricity calculations, and this actually is 4 sheets of notes, so we'll do this in a few videos. It says Ohm's Law, you should know that from grade 9. PET, you should know from earlier in this course, and PIV, which will be coming up. So from grade 9, we had Ohm's Law, named after George Ohm, and if we look at the voltage applied across a resistor, we got a current, and what we saw is as the voltage got bigger, the current got bigger. And so we end up with this direct relationship. And if we found the slope of that line, it would be called the resistance. So you're not going to have to worry about graphing, but you are going to have to worry about this. V stands for voltage measured in volts, capital V, named after volta. I is current measured in amperes, capital A for ampere, who you may have seen that in an earlier video. And R is the resistance, the drag, the force that resists the flow of electrons. It's measured in ohms, and that's the omega sign from the Greek alphabet. So the point of this is, if we increase the resistance, we're going to have less current. It's going to be harder for electrons to flow. And if we have less resistance, we're going to have a higher current because it's easier for them to flow. So we end up with this verb business here, and we saw that up there, and things we should know. 1 coulomb is 6.24 times 10 to the 18, so it's a counting tool. So 1 volt is 1 joule per coulomb, 1 joule of energy on 6.24 times 10 to the 18 electrons. So a lot of electrons it takes to have just 1 joule of energy. Ampere is the flow rates, that's why it's per time in seconds. And 1 ampere would be 1 coulomb per second. 2 amperes would be 2 coulombs flowing per second. Here are the 3 formulas in Ohm's law. If you're after voltage, you're using the first one. Voltage equals current times resistance. If you're after current, it's voltage divided by resistance. And if you're after resistance, it's voltage divided by current. So it's the usual game. You've got to read a question carefully, figure out what you're after. So you choose the formula. Somewhere in there, it has to give you the values of the other variables, and you just plug them in and come up with the right answer. And remember, very important to bring a calculator. So we look at this. One thing we got to keep in mind is, yeah, you're usually going to get the voltage in volts, but amperes may be in milliamps. And if it is, you've got to convert to amperes by dividing by 1,000. So it says, what's the resistance? So we're going to go R equals V divided by I. And then we take our 24 volts and we divide by 0.8 amps. 800 milliamps divided by 1,000 is 0.8 amps. So I have to put a 30, and I also need units. That's why it says ohms. Next one was the current that passes through a 120 volt circuit if the resistance is 5 ohms. So it says, what is the current? I equals V divided by R. So we're going to write that formula down. We're going to plug in our numbers. Didn't have to do any converting. And our units come out in 24 amps. So that's a good place to stop the first video. And we will carry on with this little set of notes.